Welcome to Off Hours, a conversation between John Edwards and Chris Manning.
Our last episode, we talked a little bit about the problem with electronics that can't be repaired. Recently, Matt, the watch nerd on Twitter, posted this great photo from Johan ten Hove. Sorry, Johan, if I'm mangling your name. He is a watchmaker who looks like he's based out of the UK and the Netherlands. And he had, as he says, upcycled his Apple Watch. So, of course, last episode we were talking about our problems with technology and not being able to upgrade them and not being able to repair them. And Johan has gone off and fixed the problem of not being able to repair an Apple Watch by replacing the contents of the watch with a mechanical watch movement. And I thought this was a nice little thing to do to a piece of old technology that he couldn't upgrade to a newer piece of technology.
One thing that impresses me about this particular design that he's executed, the Apple Watch homage knockoff, I don't know what you want to call it, that Moser produced.
PR stunt, I think, is the word you're looking for.
Yes. I think they would have flexed and shown off their horological prowess better had they actually offset the crown on that piece to match the positioning of the crown on the Apple Watch. And what Johan has done here, provided that this is actually a functional model, which I'm curious to see if it actually runs and operates, because he's actually not just integrated a mechanical movement into an Apple Watch case, but he also has the hands operating on the rear of the movement so as to show off the mechanism while also displaying the time. But I see how it is feasible in the way that he has laid out the gear train. So I am curious, genuinely, to see if this is actually a functioning timepiece or whether he just assembled pieces to look like a functioning timepiece.
Based on the photo, it looks like that balance wheel is in motion. So I think that either he's gone to a lot of effort to make this into a, look like something that actually exists, or it's actually functioning, because I'm pretty sure this is a functional piece.
It looks like it is to me as well, but it's an unusual construction beyond just the fact that he has completely tailored a movement to fit inside the Apple Watch and to accommodate the position of the Apple Watch's crown. He has also taken what is normally on the dial side of the movement and fed that up through the movement where you would normally have your center wheel or your great wheel. And he actually has the cannon pinion and everything operating in between the same bridge, or underneath the bridge that you would normally have all the gears running under, whereas you would typically have that on the opposite side of the movement. So it's an impressive feat all around. So my hat's off to Johan.
Yeah, it's a great look, and it's a great way to upgrade a piece of technology with some old technology and turn it into something unique. If I ever take one of my old Apple Watches and need to disassemble it and do something interesting with it, maybe I'll take this as a bit of inspiration and put a mechanical movement in there, because it's a great idea.
Yeah, well, when that battery eventually goes and it's had its 500th charge cycle, it's all downhill from there.
It absolutely is. I haven't gotten to that point yet with my watches, but I probably will at some point.
You're still running the first gen, right?
I have the Series 0 watch, which is the very first gen one, and I also have a Series 2, which was the one that they came out with after, I guess that's sort of the second major revision of it. And this is the one it had a slightly faster processor in it, and it was legitimately waterproofed as opposed to the first one, which was sort of splash resistant. I think the first one was water resistant down to 1 meter, and this one is good down to, I want to say, 50 meters. I may be wrong on that. Anyways, this one they actually tell you can swim with. So for me, it was a nice upgrade because I do swim with my watch on a regular basis, and I do enjoy it quite a bit as a tracker for my swimming workouts. But this isn't the newest one that has the LTE connectivity built into it. That wasn't enough of an upgrade yet for me to be interested in it.
So is your Series Zero serving a purpose elsewhere, or is it just collecting dust?
It is currently sitting on the wrist of a friend. I gave that to him to wear for a while and see if he enjoyed it, and he has enjoyed it. So I have left it on his wrist as I was not using it for anything. He's been continuing to wear that for the last, I guess, close to a year now. I also have some follow-up from our pen episode, Ink of Choice. And during that episode, I said that the Twisby Pen Company was South Korean. They are not. They are Taiwanese. I apologize for that mistake, but they are Taiwanese, not South Korean.
So earlier this week, I was flipping through a copy of the book Antiques of the Future. I came across an eraser in there that reminded me somewhat of what you mentioned doing with the ruler in the Sketch app, or pardon me, the Notes app when you're sketching, to kind of do nice, straight, very precise eraser lines. I'm just curious, given your penchant for writing instruments, whether it's an eraser you've heard of before. I was the Kokuyo Kadokeshi, which has 28 different corners on it that you can use to do some very precise erasing. It looks like an array of small blocks.
It's not something I've ever heard of, to be honest. Back in high school and middle school, I did some drafting classes. It was one of the options we had for sort of shop class credits. The most common technique for accurate erasing that we used were eraser shields. And they're thin stainless steel sheets that have various shapes stamped out of them. And they're relatively small. And so you could choose the appropriate size and use it to just reveal the line or the part of a line that you wanted to erase. And that way you didn't have to try and precisely erase something with your, misshapen eraser. It's a surprisingly effective and fast way of accurately erasing lines. I'm curious to take a look at this and see what it looks like. But I think that if you asked me today to sit in front of a table and draw something and I needed to erase things accurately, I would go into my pencil case and grab an eraser shield before anything else, just because they're inexpensive and they're very easy to use.
Yeah, I tended to, or I shouldn't say tended to, still do rely on kneaded erasers when I'm drawing freehand. I'm able to make very fine points with that, which is very similar to Watchmaker's Rodico. And actually, when I first started out in watchmaking school, I tried using one of my kneaded erasers as Rodico, as I hadn't yet invested in any. Doesn't work very well. I don't recommend it at all.
Don't recommend it. Yeah. There is an eraser. I will have to dig up the name of it. There is an eraser that we found that is outstanding. It's a black rubber eraser. I will dig up the link for it because I can't remember off the top of my head where it's from or what the name of it is. And they're absolutely fabulous. They are by far the best erasers I've ever found. Now, they're fairly solid. You can't shape them like the erasers you were talking about. But I find that they do a fabulous job of cleaning up lines and removing the line work that you want to without damaging the paper or the substance underneath. So I will dig that up as my favorite eraser because they are fabulous. We have probably a dozen of them sitting around here.
Surprisingly, I have found in the past that just a standard drafting eraser, there's the white chunky ones, are actually quite useful for, not in all cases, but in some cases of light corrosion on, say, a bridge or a main plate or a brass component. It's actually very good at just wiping that away before throwing it into a cleaning machine. You get a nice bright finish back on the piece rather than having that mild light coating of corrosion being left, and it doesn't damage the part at all.
Well, it will act as a mild abrasive, right? So that's really what it's designed to do, but that would be fairly gentle and would definitely remove something without damaging the material underneath. So yeah, a lot of oxides are just a thin layer on the surface, so that would certainly be a good way of cleaning it up. Last year when I was traveling in the spring, I was in Japan for a few weeks, enjoying the sakura blossoming in both Tokyo and Kyoto. And I spent a lot of time just randomly wandering around Kyoto. It's one of my favorite cities to just walk out the door and turn a random direction and start walking, because everywhere you go, there are these fabulous temples and gardens and little delights that you find down odd streets. While I was there, I saw advertisements for a Van Cleef and Arpels show that was going to be at the National Art Museum. And sadly, it was opening the week after I was there. And I didn't find that out until I was at the box office for the museum, and I was being told, no, you're wrong, you're a week early. And I was looking for something to do. So I pulled up Apple Maps, and I found this marker for a Cloisonné museum. And I thought that was a little bit odd to find in Japan, and I wasn't aware of the tradition of enamel work in Japan. I'm very familiar with the urushi lacquerware tradition in Japan. That's been used in a number of different arts, everything from small boxes and plates and dinnerware and things like that, all the way to use on armor and to help protect and preserve armor. But I wasn't aware of the history of enamel work in Japan, so I decided to check it out. It was a bit odd because normally you're expecting a museum to be on a main street or whatever, and I'm following the map directions, and I end up on this small residential street standing in front of a residential house. And lo and behold, there's this small enamel museum, this Cloisonné museum. And it turns out that this building was the house and workshop of Namikikawa Yasuyuki, who is probably the most renowned Japanese enamelist of the Meiji period. The Meiji period, for those who aren't familiar, is 1868 to sort of 1912. It's just after Japan is opening up its borders to the outside world again. Japan up until 1867 was very insular. And during this time period, Namikikawa is producing this stunning enamel work. We'll put some links in the show notes for you to check out. He's mostly doing small vessels, vases, urns, occasionally cigarette cases. And he has a small number of artists who are working with him. And this museum is his house. This is where he was living. This is where he was working. And the house has been preserved along with quite a few of his pieces. Now, I'm not sure how this collection stacks up in terms of other collections of his work in the world. I know that one of the most significant collections is owned by the Japanese royal family. They were significant collectors of his work at the time, and there are a few other collections around the world. That I think there's one in LA that have a number of his pieces. And I was pleasantly surprised walking through this exhibit and seeing these stunning pieces of work. And I think the thing that surprised me the most was just how delicate and refined the Cloisonné work is, and how perfect it is. So I wanted to talk a little bit about enamel work, give an overview of what enamel work is, and also talk a little bit about these pieces because they're absolutely fabulous. Obviously, it translates a little bit into the watch world and into some of the stuff that I do, because there are enamel dials being used on watches. As I mentioned in the show about SIHH, one of my favorite IWC watches had an enamel dial on it, and for many years, enamel was sort of the standard for a watch dial.
A good place to start might be to define exactly what Cloisonné enamel is, because it's quite an involved technique and requires a fair bit of foresight and planning before you even begin to apply the enamel.
I should start even a little bit earlier than that and talk about what enamel is.
Mm-hmm.
The enamel is a term that's used for a number of different things, everything from your teeth to coatings on a steel tub to jewelry work. And its meaning has sort of morphed into a lot of different things. Traditionally, what I'm talking about here is vitreous enamel. And this is a glass that has been fused at high temperature usually to a metal substrate. And the metal could be copper, it could be silver, it could be gold. There's also enamel work being done on steel and things like that. So when I'm talking about enamel, and when we're talking about it in the context of watchmaking and jewelry making, typically we're talking about vitreous enamel. So it's a glass, effectively. Sometimes you'll see it referred to as hot enamel or hard enamel. And it's something that requires a great deal of skill to do well.
Mm-hmm.
There are a lot of people who do it poorly, but to do it well takes a great deal of skill.
A term that's often used in the watch industry, being a predominantly French-speaking industry, is grand feu enamel, which just means big fire.
Yes, exactly. Yeah, and that's sort of where the hot enamel term comes from as well. But you're right, grand feu is a perfect term for it. You also see a lot of people these days trying to pull off fake enamel by using modern epoxies. There are various colored epoxies on the market that aim to replicate the enamel work that's out there, and they don't require nearly as much skill, and they don't look as good. They're often filled with small air bubbles in them, and most importantly, they don't have the same index of refraction that glass does. So you don't get the same fire out of them as you do out of an enamel, out of a proper glass enamel. Don't be fooled if you're looking at something like a pen. If you're looking at a pen and it's relatively inexpensive and it's relatively light, and they're telling you that it's enamel. It probably isn't. It's probably an epoxy, and it's just a colored epoxy that's been used. Because it's glass enamel, vitreous enamel is quite heavy compared to something like an epoxy or a plastic. It is delicate to some degree. It's remarkably durable considering it is glass, but it is certainly delicate compared to a piece that's being done out of, say, straight metal or even plastic. A lot of plastics are more durable than enamel in terms of shattering or breaking. One of the reasons that enamel has been used for so long, and we have examples of enamel work going back to the Romans and the Egyptians, so the enamel work is certainly something that's been used for a very long time. One of the reasons that it's so popular is because the colors don't tend to change over time, and they don't get affected dramatically by UV light. So many things that are used for coloring, whether it's paints or dyes, they tend to be affected dramatically by UV light over time, and so they don't stay color fast. One of the beauties of enamel is that it is very durable in terms of its color, and so we have gorgeous medieval pieces of enamel that look as vibrant today as they did 500 or 600 years ago. Now, in terms of enamel techniques, we were talking about cloisonné enamel. There are a number of different enamel techniques, and most of them have to do with a way of containing the enamel and giving it sort of solid sides. One problem with glass is that a raw edge is not very strong. You really need something supporting that edge. So most of the enamel techniques that are out there, are various ways of creating a pocket or some sort of an enclosed area for the enamel to be contained in, so that edge is not exposed. In the case of cloisonné enamel, they are using a very, very thin wire. Think of something that's maybe about the thickness of a sheet of paper, and it's going to be, let's say, 1.5 millimeters, 2 millimeters wide. That wire is shaped into these small cells. The cells are then placed on top of a base piece of metal, whether it be a piece of copper or silver, gold, or whatever, and they're held in place by the enamel as it's fired. The enamel will then be filled into those little cells, and so you get these discrete little blocks that you can shape into whatever you can shape them into. to create patterns, and you get these sort of fine silver wire lines or gold wire lines between the various cells, and it helps to not only give an edge to the enamel, but also allows you to put different colors of enamel side by side to then create colored patterns. Cloisonné enamel is certainly one of the more challenging styles and techniques of enamel to do well. Those small cloisons take immense skill and patience to form and to place on the base vessel, and then not disturb them as you're enameling, and fill them properly with enamel, and then fire it. And so it requires an incredible amount of skill and patience to do. Should also mention, we were talking about it being called hot enamel or grand feu enamel. The reason for that is because of the temperatures that you're using for it. Typically, when you're firing enamel, you're putting it into a kiln at somewhere between 750 and 850 degrees Celsius, which is around 1350 to 1550 Fahrenheit. So you're firing it at very high temperatures. In fact, you're firing it at temperatures that are very close to the melting temperature of the base metal often. You're within 100 degrees or so of the melting temperature of some of these metals.
Mm-hmm.
And you're not putting the piece in for very long, but just long enough that it allows the enamel to melt and flow and become a liquid. And in the process, it sinks down into the recess that you've created. And it also fuses to the base metal. When you have a piece of enamel, it's not just a discrete piece of glass that's sort of floating over top of the metal. It is actually fusing to the base metal.
Mm-hmm. And in that light as well, you mentioned the enamel holding the wires in place. That is certainly the modern method, but early pieces, to the best of my knowledge, for instance, stuff from, say, the Roman Empire, or even up in the medieval ages and further still, they would actually but they would solder the wires in place before applying the enamel. But this tends to have the effect of discoloring the enamel that you're applying because of the temperatures that you end up reaching when you're melting the glass. So the more common technique or preferred technique in this day and age is to use a very high temperature clear or white enamel underneath the cloisons to melt and fuse those in place. And that would be a very high temperature melt for that particular enamel. And then that holds everything in place and prevents the discoloring that you would get from a solder melting and fusing in with the glass.
Mm-hmm. Yeah, and it's worth talking about the discoloration and the colors of enamel. The color that you're getting out of enamel is because of various oxides, metal oxides primarily, that are added to the clear glass. And that gets you the various colors that you see in the enamel. And those colors change dramatically as you're firing it. And they can be affected by a number of things, including access to oxygen at high temperature, and also coming in contact with various metals. So, for instance, if you are using an enamel on copper and you use the exact same enamel on silver, you will end up with two different colors because the oxides in the enamel will react differently with the base metal that you're enameling on. And in the case of the solder that you're talking about, to allow the solder to flow at a lower temperature than the base materials that you're soldering together, you end up with a slight discoloration because it's a different metal that's in there, and so it doesn't look the same as the pieces around it. The one big challenge with using solder on a lot of these pieces is that you have to use relatively heavy wire when you're using solder, because otherwise the thin wires that people tend to use today, and certainly the thin wire that were being used in the examples from Namikikawa, they wouldn't survive a soldering process. They're just too thin and they don't have enough mass, so they would end up balling up pretty quickly. The enamel tends to act as a bit of an insulator for the wire as it's being fired.
From what I could tell from the work you showed me from Namikikawa, the wires are almost invisible in some cases.
Yeah.
It's so fine. It's absolutely incredible work. He's a master of his craft.
I guess people started using Cloisonné enamel in the middle of the sort of the Middle Ages, and at the time, the wire that they were using was relatively coarse compared to what we see in modern pieces or more modern pieces like this. And I don't think I've ever seen anything done as delicately as these cloisons. They're just remarkable how thin it is, and in fact, that cloison wire is almost a foil as opposed to a sheet or a wire like what we think of. So seeing these delicate little flowers being created, sometimes on vessels that were only 15 centimeters tall, and you get these gorgeous sort of sprays of flower being rendered on these tiny little vases. It was just remarkable.
Mm-hmm.
And in fact, if all he was doing was producing these small vases in copper or silver, they would have been exquisite by themselves. They had a couple of examples of pieces that hadn't been enameled yet. So they were small vases that had survived from being fabricated, and then they were being raised from flat sheet. And he had never gotten around to actually enameling them. And just these little vases, the shapes of them are absolutely perfect. The proportions and forms of them are absolutely perfect. And then on top of that, he's applying these cloisons in this enamel on as well. Everything from small pieces that were, as I said, maybe 15 centimeters tall, all the way up to large vases that are maybe a meter in height. And it didn't matter what size of piece you were looking at. All the enamel was absolutely perfect. There were no flaws in it. There were no little air pockets in it, no discoloration. It was just remarkable how perfect all these pieces were.
Mm.
My introduction to enamel work came primarily through medieval pieces. Enamel was a popular way of adding color to metalwork in the Middle Ages because it was a relatively inexpensive material, and at the time, colored stones were not common or accessible. So trying to get colored stones in the range of colors that you can get enamels in just wasn't possible 600 years ago. Whereas today, we can often get whole ranges of colors, whether they're natural stones or synthetics. So it's a little bit easier to add color using colored stones today. But before that was common, really the only way to add a wide range of color to a metalwork piece was to enamel it. So that was my first introduction of that, seeing pieces in the British Museum and the V&A. My real interest as an artist in using enamel came from trying to replicate the Fabergé work that I was seeing. So the first part of that was to do the engraving, the guilloché work underneath. Mm. But then the real beauty of the work that Fabergé was doing was taking that guilloché and then covering it with translucent enamel so that the light can shine through the colored glass, hit the engraving work, and between the index of refraction of the glass and the change of direction from the engraving, the bright polished engraving, you get fabulous moire effects and colors coming out of the enamel thanks to the combination of the two. So when I started trying to enamel, I was using it primarily from the point of view of enameling on top of guilloché work. And there are a few pens that I did early on that were done like that. So in that case, I'm taking a base piece, engraving it on a straight line engine in my case primarily, or a rose engine, and then applying a translucent enamel over top of it so that you can get access, or so you can see down through it to the engraving underneath.
Now it's difficult enough to do enamel work well on a flat surface. How did you pull off applying the enamel on a cylinder the way that you did without drips forming and that sort of thing?
In typical Chris fashion, I decided to start by doing some of the most challenging work in a particular art when I picked up enameling. So most people, when they pick up enameling, they'll start with opaque enamels. They'll do a flat surface, and it's very easy to work on. But of course, I wanted something that was cylindrical, like a pen, and I wanted to do translucent enamel, and I wanted to do it over guilloche. And so, of course, I didn't have the patience to do all the steps leading up to that. So I just dove straight in and started working on cylinders. And fortunately, you get to take advantage of a few of the physical properties of glass and a few effects of physics that allow you to sort of get away with it. When you're enameling and you're fusing that glass in place, it's melting and it's becoming a liquid. It's very thick and it does not flow quickly. It also has a very high surface tension. And so it tends to stick to itself and not sort of run off and leave an area quickly or release itself from an area of metal. So I should say, when you're doing enamel work, you don't fire the enamel in one thick layer. You need to do it in multiple thin layers and build up the thickness of enamel that you're going to end up with. And when I'm firing something like a pen cap or a pen barrel, it's typically in the kiln for less than 2 minutes. So it doesn't really have a chance to flow anywhere and sort of get out of hand. If it does, I can just simply turn it over. So I tend to use a stainless steel jig that holds the piece horizontally. And if I need to, I can actually rotate the barrel on it. It's just sort of sitting loose on this mandrel.
So this is while it's in the kiln or while you're applying the enamel, or both?
No, while it's in the kiln. And so I'll actually give it a bit of a rotate if I need to prevent it from settling too much. But really, a lot of it comes down to I'm taking advantage of the fact that it doesn't flow quickly and it has a very high surface tension. And you have to pay attention. If you are distracted in any way, and instead of leaving it in for 120 seconds, you leave it in for 150 seconds, all of a sudden you end up with these puddles sort of dripping off the bottom of the piece. So it's various things that allow you to take advantage of the properties of the glass as it's melting and as it's heating up, and paying attention and patience. There are a lot of different things involved. I'm not saying that it's easy. It is quite challenging to do well, but it's certainly doable, and it's not impossible working on 3D objects. But it isn't as easy as working on something flat. So if you're out there and you're thinking about enamel work on something flat or work on something that's slightly domed, and it'll be much, much easier to work on when you first start.
Have you ever needed to do any post-processing on any of the enamel work that you've done, or does you usually get a nice finish straight out of the kiln?
Well, there's a few things that happen with enamel when you're working on it, and let me explain a little bit about how enamel is applied to the work. When you get enamel, you typically get it as small lumps of glass. Think about something that's maybe the size of a pea. And you then crush it in a mortar and pestle and turn it into a powder. Now, the thickness of grain that you end up with in the powder, it does affect the way that the enamel functions afterwards, and you have to be careful, especially when you're using translucent enamels. If your powder is too fine, then the enamel tends to become cloudy. But if it's too large and too thick, then you don't get good coverage when you're working with it. So it's sort of a fine balance of how you grind up that enamel into powder. But you do end up with a powder. And think about it, I would say maybe the largest grain size that I would use is probably similar to what you would see in table salt. and the finest that you might get is almost like an icing sugar. But that I find is too fine, and I don't get very good results with that. Although I do know enamelists who do get good results with it. So there's a bit of sort of black magic that's involved with enameling. And, your results may vary depending on your skill level and what you've been able to figure out. But I find that something that's maybe a little bit smaller than a grain of salt is typically what I work with. From there, you will spray a bit of a binder onto the workpiece. In my case, I'm using a product called Clearfire, and it's usually a diluted solution of that. And so you spray it on, and it gives you something. It gives you a wet surface for the powder to stick to. And once it dries, there's a little bit of a binder in there that sort of gently holds it all together. So it's not just a loose mass of powder that's sitting on it. If you're working on something flat, then you don't necessarily need a binder. You can get away with it. And if you can get away with it, it's worthwhile doing that, just because the binder is another additive that's in there that it has to burn off and can affect your work. So if you can work without a binder, then that's ideal.
Now, at the museum, did they touch on the process that Namikikawa used for applying the enamel that he used? Like, what sort of carrier he would have used, like linseed oil or?
Probably wouldn't have been a linseed oil, and there may have been details in there, but unfortunately, my Japanese is nowhere near good enough to be able to read
Touche.
The notes that were being posted, and there were some English cards and things like that of details. And one of the nice things was that they still had part of the workshop set up with raw materials and things like that, which was nice to see. The original kiln is gone, unfortunately, but they did have some enamels and tools and things like that, which was wonderful. Sadly, they didn't allow people to photograph in there, which is disappointing.
I can imagine, like you, he wouldn't be able to just drop the grains of glass into the cloisons.
No, and they're probably using something like a gum arabic as a binder, a watered down gum arabic. Now, they were using a slightly different technique. In my case, as I said, I'm spraying my piece with this Clearfire solution, and then I use a sieve to sort of sift on the enamel over top of it, and it sticks to the part, and then I can sort of rotate it and cover, put a thin layer of this powder all around the cylinder. They're using a slightly different technique called wet packing. And in that case, what you do is you mix up the powdered enamel with your binder, and you have a sort of a mud that you create with it. And you then take a brush or a small spoon, and you actually delicately put it into the areas that you're working in. A lot of cloisonné work is done like that, where you're taking this wet pack enamel and you're actually filling in this cell with a small spoon to get it in place. And so they would slowly go over the entire piece, covering it with this wet pack enamel. Think of actually a good way of thinking about it would be something like wet sand. If you're at the beach and you see wet sand, wet pack enamel is maybe a little bit drier than that, but it's very similar, where you can sort of take it and pack it into an area, and it'll sort of stay and behave with where you put it. And so they would laboriously cover a piece. I suspect that some of those pieces would have taken days, maybe weeks, to put a layer of enamel down on. Again, once you've finished that, you have to make sure that you let any liquids dry. So any water that's in there has to dry before you can fire it. Because when you're putting something like that into a kiln at 1500 degrees Fahrenheit, that water will vaporize instantly. And you can actually have blowouts where the steam coming off of it will dislodge the enamel that you're working with. It will sort of shoot it off of your piece, and you'll end up with these small pockets where you once had enamel and now you don't.
Yeah, I've seen some of the dalle work done by Donze Cadrin in Switzerland, where they will, because you have to go through multiple phases of applying the enamel, you can end up with these bubbles. in the enamel work. If you're not able to fix them, having to throw away potentially days of work. And I've seen where their artists will sometimes, if the bubble is small enough, actually chip out the bubble from the enamel and apply a small amount of enamel back in that cavity and then fire it again to rescue the piece.
One of the advantages with the work that I have is I'm typically working on a larger piece, and the area that I'm working on is larger. Now that has its disadvantages, but it also has an advantage in that if I see a small air bubble in there, and that air bubble is often caused from either the binder, the clear fire that I'm using, it doesn't come out of the solution entirely, like it doesn't get sort of come up to the surface of the glass as I'm firing it. Or it may be because there was a little pocket between the grains of enamel and I didn't leave it in long enough, or it wasn't hot enough to sort of completely fuse in that space. So sometimes you'll see larger or smaller air pockets that end up forming in the enamel. And in my case, I can usually grind away the enamel around it to reveal that pocket. And then when I put down a subsequent layer of enamel, it fills in that space for me. So the process that I go through typically is to put down a thin layer of enamel, let the binder dry, put it into the kiln at high temperature, leave it in there for 2 minutes, let it fuse, take it out and let it cool down. And then I will grind it down to a regular surface again that is quite thin, often removing a bunch of enamel that looks like it could be good, but I will actually bring it all down because it's uneven at that point. So I'll bring it down to a regular layer again, and then I'll apply a little bit more binder, another thin layer of enamel, let that dry, fire it, and repeat that process. And for something like my pen barrels, you're looking at a thickness of glass that's probably somewhere around 1/4 millimeter. So it's maybe 10,000ths of an inch thick. And that layer of enamel will be built up over 3 or 4 layers. So that thickness of enamel will be built up over 3 or 4 layers. And the final layer will actually be a little bit proud of where you want it to end up, so that you can then grind it down to the surface that you want and the dimensions that you want.
So are you using a bench grinder for this, or a small handheld rotary tool?
No, it's all being done by hand.
So you're grinding with sandpaper by hand then, or?
No, not sandpaper. Typically you're using stones, various grinding stones. So think about something like a stone for, like an Arkansas stone for polishing or for sharpening a knife blade. It's going to be a hard stone. We don't use Arkansas stones, but it's something similar. I also use a lot of diamond abrasive. So there are sticks that have various grits of diamond abrasive on them. And those tend to be my favorite because they risk of embedding particles of your grinding stone into the enamel is low. You know, you're grinding away with the diamond, and it's and so I'll reduce the surface using, just like you would with sandpaper, start with a coarse grit and work your way down to a finer and finer grit. And from there you can have a few different choices in terms of how you finish it. Ideally, what you want to do is you want to put the piece back into the kiln for 30 seconds, and you just let the surface become a liquid, and it fills in all the little scratches that you've just put in with the abrasive. And then you pull it out again, and you end up with a beautiful, smooth, shiny surface that you're working from. You can also use various fine abrasives on, let's say, a leather strop to make it, to get a very, very fine, highly polished surface out of it. The disadvantage of working in something like Cloisonné enamel, you can't easily do what I do, where I grind away an area and reveal a pocket or an imperfection. If you're lucky, you can use something like a rotary tool to get in there and actually grind it away, but it really depends. And of course, if you do that, there's always the risk that you're going to damage the cloison instead of taking away the enamel. So you do have to be very careful about that when you're working on it.
Mm.
And as you say, it's very easy to ruin a piece and end up needing to redo all of the work that you've done, because enamel work is typically the last thing that you're doing on a piece of metal work.
Mm-hmm.
And so in the case of my pen barrels, I might have 10 or 12 hours of work into a cap by the time I've deep drawn it, I've engine turned it, and done any machining work that I need to on it. Again, it might be 10 or 12 hours worth of work before I get to the enamel work. And then the enamel work might end up being another 3 or 4 hours of work on that cap to enamel it and grind it and polish it and everything. So it is challenging because it has a very high failure rate, and any imperfections will jump out at you.
Mm. Now, in light of that high failure rate, it makes the breadth of work that he was able to turn out in his lifetime is just incredible, really. You can tell that this was a true craftsman who dedicated his life to his craft, to hone it to the level that he did, and to be able to turn out such a broad body of work.
One of the advantages that he has is that he's working in an opaque enamel.
Mm.
The chances of the enamel discoloring are much lower than they are with translucent enamels. You still get some discoloration probably with the enamel that's closest to the metal. However, you don't see it because it's not visible. There are layers of enamel over top of it which are protected by the lower layers of enamel.
Mm.
That's one of the advantages in the work that he's doing, is that most of it tends to be opaque enamel, or it's a translucent enamel that's being painted over top of an opaque enamel, so that you're getting, let's say you have a white enamel on the bottom, and then you've put a translucent enamel, let's say a pale pink or something on top of it, and so you see the white coming through the pink, to change the color of it a little bit. So that is one advantage of working on with an opaque enamel, and that's one of the big disadvantages of working with translucents, where, like the work that I'm doing, or Fabergé. Now, the other thing to realize, and this is the same thing with so many of the artists that we think of, he was not working alone, just like Fabergé is not working alone. He had a small group of talented artists who were doing a significant amount of this work for him. His name was eventually going on the pieces, but there were very skilled craftsmen who were helping him. And I think I was reading an article recently about him, and I want to say there were either 10 or 20 artists that were working with him. And so a lot of that work, a lot of the painstaking work of filling in those cloisons, for instance, would have been done by sort of junior artists that were working under him. Just like if you go through Fabergé's work, there are scores and scores of workmen that are in the various workshops. And so a lot of that work is being done by, skilled jewelers, skilled metalsmiths who are working in the workshops. And even though it's somebody else's name that's going on it, at the end of the day, there are a large group of people that are working on it. So anytime you see these artists with large outputs of work, and especially in a complex art like this, there's probably some group of apprentices or artists that are sort of junior artists that are working with them to assist them. For better or worse, our labor laws don't allow us to employ people the same way that they did. So I can't employ 13-year-olds as junior apprentices and make them indentured servants for 7 years to learn my craft. And so today we have to take advantage of things like CNC equipment and rapid prototyping and mechanical means for polishing and things like that to help move things along, just because we don't have the labor force, the inexpensive labor force and the young labor force primarily that was being used by a lot of these artists early on, to sort of do the bulk of the grunt work on this stuff. Before
we wrap things up, I think it's worth touching on Namiki Kawa's kitchen and backyard, because they stuck out to me as well in the pictures that I saw there. This museum being in his house, it was neat to see where he lived his life and some of the beauty that I'm sure he drew some of his inspiration from.
One of the things that drew me to this museum, I spent a number of hours there. It's not a very large museum. I think the work that they have is presented over 3 or 4 rooms. It is not very large. And as you say, this is still as it was when he was living there to a large degree. So his living room is still furnished the way that it was when he was alive. The gardens that surrounded his house, this beautiful little pond, and the garden that was surrounding it. He had a number of koi that he cultivated in his pond, and one of the things. So they've done a remarkable job of maintaining the house as it was. I believe he died in the mid-20s. So the house has really been maintained the way that it was in the mid-20s, which is remarkable. I don't know how. First off, the fact that it survived to the point where somebody could buy it up and turn it into a museum, and then be able to maintain the furniture and everything the way that it is remarkable. So it certainly speaks volumes of who he was during his lifetime. So many artists, of course, are not really recognized during their lifetime, but clearly he was recognized for his ability. And this house was maintained as well as it is. The neat thing about it, again, just a gorgeous place to work. I dream of having a shop of with having sort of this, being surrounded by this beautiful scenery. But on top of that, they've maintained the original kitchen as it was in the 1920s. I think the stove is missing from it, but the original well that the household was using to draw water from is still there. It's just a remarkably preserved building. Certainly, if you're in Japan, I recommend going to Kyoto. It is a beautiful city, and it's worth spending weeks wandering around. But on top of that, if you are in Kyoto, make an effort to visit this museum. It's remarkable work. Fortunately, it's not very far out of the sort of the central area. It's very close by to some of the major museums that are there. So you're not really going out of your way to get to it. But yeah, the original structure, the keeping everything the way that it was is just it's nice to see. It's nice to see the work in the environment that it was being made, and you can see the inspiration that he's taking from nature around him in the work pieces. So certainly a remarkable museum. So we've sort of jumped around a little bit, and we've focused a lot on the work of Namikikawa and some of the work in Watch World and what that represents. But we're going to come back and discuss enamel work more, because there's a lot more to dive into here in terms of the different techniques that were available. So certainly some remarkable things that were being done, and I think it's worthwhile discussing a little bit more what the history of enamel work and some of the different techniques that are out there, things that we just don't see very much anymore. And yeah, we will revisit enamel work at some point in the future.
Yeah, absolutely.
Thanks for listening to Off Hours. You can find detailed show notes at offhours.show. If you'd like to keep up to date with the show, follow us on Twitter @offhours. John can be found on Twitter @UnderTheLoop, and Chris can be found on Twitter and Instagram @silver_hand.